Hello, and thank you for joining me on this journey. Tonight, we will slowly drift into the serene embrace of water, the soft currents of rivers, the vast whispers of oceans, and the hidden life beneath their surfaces. Imagine the formation of water molecules in distant stars, cascading through time into the streams and glaciers of our Earth. Feel the cool touch of morning dew on leaves, the distant ripple of a hidden river, or the hush of waves lapping against a quiet shore. Allow yourself to float alongside this quiet power, noticing the subtle connection of water to every living thing, every landscape, and every breath of air. If you enjoy these relaxing moments, please consider leaving a like, subscribing, and turning on all notifications so you don't miss any of our future videos. But for now, just breathe. Let your body relax, release any tension, and allow your mind to drift. Let's begin. Water in clouds often forms intricate microscopic crystals that capture sunlight, scattering it in a delicate array of colors. As these droplets coalesce, they shape the clouds' towering forms, drifting across vast skies. Atmospheric currents guide them across continents, linking weather systems, sustaining rivers, nourishing landscapes, and creating an unseen network that balances the Earth's water cycle with subtle, perpetual motion. Beneath frozen polar surfaces, subglacial lakes exist, harboring liquid water kept warm by geothermal heat. These hidden aquatic reservoirs are isolated from the surface for thousands of years, supporting microbial life adapted to extreme cold and pressure. Scientists study them as analogues for extraterrestrial oceans, revealing how life might persist in icy worlds far beyond Earth. Rainwater that lands in tropical forests seeps into dense root networks, feeding not only trees, but also fungi, insects, and bacteria that recycle nutrients. This underground symphony sustains the vibrant greenery above, while the constant flow of moisture maintains humidity, prevents soil erosion, and allows streams to swell with vitality, reflecting dappled sunlight through thick, layered canopies. In deserts, ephemeral rivers surge briefly after storms, carrying silt, seeds, and minerals downstream. These fleeting waterways shape valleys, replenish oases, and provide temporary habitats for amphibians, insects, and migratory birds. Though invisible for much of the year, they leave scars and sediments on the landscape, silently chronicling the rare but powerful impact of water in arid environments. Frozen oceans may exist on Neptune's moon Triton, preserved beneath a thin crust of nitrogen ice. Subsurface activity, possibly from tidal forces, could keep water liquid at depth. This scenario highlights how distant, frigid worlds can harbor stable liquid reservoirs, emphasizing the adaptability of water to extreme pressures, temperatures, and chemical environments far beyond the habitable zone of our solar system. Water-rich. Plumes on dwarf planet Eris have been theorized to occur due to sublimation of subsurface ices combined with cryovolcanic activity. While largely speculative, these phenomena suggest that even the coldest, most remote bodies in the Kuiper Belt may exhibit dynamic water movement, influencing surface reflectivity, atmospheric interactions, and the potential for chemical reactions over geologic time. Saltwater ecosystems thrive with intricate interdependencies. Coral reefs, hidden beneath shimmering waves, host a dazzling array of fish, crustaceans, and algae. These reefs filter nutrients, protect coastlines from erosion, and respond to subtle temperature shifts. Each ripple across the surface conveys energy that sustains life far below, while the constant chemical dance within seawater shapes both ecology and global ocean currents. Mountain streams carve steep ravines, polishing stones into smooth sculptures over centuries. Their waters carry minerals that nourish valleys, forests, and grasslands below, while the rhythmic sound of flowing water indicates ongoing geological activity. In their channels, aquatic insects glide, trout dart, and mosses cling, illustrating the profound connection between moving water and the delicate ecosystems it supports. Fog forms when warmer air meets cooler surfaces, condensing into billions of tiny droplets suspended in the atmosphere. These low-lying clouds carry moisture to forests, mountains, and coastal plains, often depositing hidden rainfall on leaves and soil. Beyond nourishing life, fog scatters light, softens outlines of terrain, and transforms ordinary landscapes into ephemeral, mist-filled panoramas that evoke subtle awe. Water molecules possess an extraordinary ability to store heat, giving oceans and lakes their capacity to moderate climate. This thermal inertia slows temperature swings across seasons, ensuring that ecosystems along shores, wetlands, and river deltas remain habitable. Currents distribute heat unevenly, driving weather patterns and allowing diverse flora and fauna to flourish, from tropical mangroves to temperate marshes. Tides, influenced by the gravitational pull of the moon and sun, rhythmically lift and lower coastal waters. This motion transports nutrients, reshapes shorelines, and creates intertidal zones where organisms adapt to constant change. Shellfish, algae, and seabirds thrive within these zones, dependent on the subtle, perpetual ebb and flow that defines the interface between land and ocean. Ice sheets in polar regions slowly compress snow into dense, bluish ice, storing immense volumes of fresh water. As they shift and fracture, they form crevasses, ice caves, and floating ice shelves. Their mass affects global sea levels and ocean currents, and the interplay of sunlight and shadow across these frozen expanses creates landscapes of mesmerizing geometric and color patterns that evolve over time. Springs emerge where groundwater meets the surface, often carrying dissolved minerals that color rocks and sediment. These flowing sources provide drinking water for wildlife and humans alike, sustaining ecosystems even in areas where precipitation is minimal. The subtle sounds of emerging springs, combined with their crystalline clarity, create natural landmarks that serve as ecological hubs for both life and cultural significance. Subterranean rivers carve limestone and volcanic rock, creating caves adorned with stalactites and stalagmites formed over millennia. Drip by drip, these underground waterways sculpt spaces that shelter rare species of fish, crustaceans, and microbes. The interplay of light entering cave mouths and shadowy recesses enhances their ethereal appearance, turning simple geological features into hidden, almost otherworldly aquatic realms. Rainwater harvesting in ancient civilizations shaped human settlement patterns, influencing agriculture, city planning, and trade. Ingenious canals, cisterns, and aqueducts transported water across arid regions, supporting crops and livestock. By channeling this vital resource, societies flourished, and their remains today still hint at the ingenuity inspired by water's centrality to life, civilization, and survival. Glacial meltwater flows into rivers with a pale, milky blue hue due to suspended rock flour. This mineral-rich water nurtures downstream soils, feeds fish populations, and contributes to the overall fertility of valleys and plains. The slow seasonal melt ensures a consistent supply of fresh water, linking icy highlands to distant lowlands and connecting ecosystems separated by hundreds of kilometers. Water absorbs sunlight differently depending on depth, creating gradients of color in lakes and oceans. Near the surface, warmer, lighter hues emerge, while deep regions appear dark and mysterious. This vertical layering affects temperature, dissolved oxygen levels, and the distribution of aquatic organisms, demonstrating how even subtle shifts in light and heat dictate the intricate choreography of life below the surface. Steam rising from geothermal vents carries minerals and trace elements that nurture unique ecosystems. Microbes thrive in temperatures that would be lethal to most other life, forming colonies that transform chemicals into energy. These hidden aquatic oases reveal Earth's ability to sustain life in extreme conditions, hinting at the remarkable adaptability and resilience inherent in water-dependent ecosystems. Wetlands serve as natural filters, purifying water as it passes through roots, sediment, and microorganisms. These marshes and swamps absorb pollutants, regulate water flow, and provide shelter for birds, amphibians, and invertebrates. The interplay of still pools, reeds, and meandering channels creates dynamic habitats, demonstrating how water both shapes and sustains complex ecological networks, while quietly performing essential environmental functions. Exoplanetary oceans may exist beneath thick ice layers on so-called ocean worlds, where tidal forces or radioactive decay generate internal heat. Spectroscopic analysis of their atmospheres can hint at water vapor, clouds, or rain. Such worlds demonstrate that water is not confined to Earth-like conditions, showing the potential for stable liquid reservoirs under ice, supporting life or chemical reactions in extraterrestrial subsurface oceans. Water on Mars exists in perchlorate brines, which lower the freezing point and allow transient liquid flows during warm seasons. These salty waters appear as dark streaks on slopes and provide insights into Martian hydrology. They reveal that even in harsh environments, H2O can persist in modified chemical forms, shaping surface features and possibly sustaining microbial life under extreme conditions. Water's density changes with temperature, allowing ice to float and insulate aquatic life beneath frozen surfaces. This property preserves ecosystems through frigid months, maintaining habitats for fish, insects, and amphibians. The subtle expansion of water during freezing also sculpts rocks, fractures shorelines, and contributes to erosion, creating a slow yet persistent force that continually reshapes terrestrial and aquatic landscapes. Snowmelt in alpine regions releases crystal clear water into streams, carrying oxygen and nutrients that sustain downstream vegetation and wildlife. As it cascades over rocks, it generates microhabitats for insects and microorganisms, while mosses and lichens cling to moist surfaces. This seasonal influx replenishes aquifers, supports agriculture, and maintains the delicate balance between terrestrial and aquatic ecosystems in mountainous landscapes. Water trapped in soil forms a living matrix, where roots, fungi, and microorganisms interact. Tiny channels allow moisture to flow slowly, nourishing plants while supporting burrowing insects and bacteria that recycle nutrients. Soil water regulates temperature, mitigates erosion, and sustains forest canopies, demonstrating the intricate interplay between terrestrial landforms and the invisible, life-giving pathways of moisture beneath the surface. Io, Jupiter's volcanic moon, is extremely dry at the surface, yet models suggest water vapor may exist transiently in the thin atmosphere produced by volcanic plumes. The extreme heat from active volcanism contrasts with trace H2O, showing how even tiny amounts of water can interact with dynamic geological activity, influencing local chemistry and potential niches for extremophile-like processes in planetary exploration studies. Water ice on distant Kuiper Belt objects remains stable under extremely cold, low-pressure conditions. These frozen reservoirs store ancient H2O from the solar system's formation, offering a window into primordial chemistry. The slow evolution of these ices through cosmic radiation and micrometeorite impacts preserves molecules that may have seeded planets with water, highlighting the role of distant, icy bodies in the broader distribution of liquid essential compounds. The movement of groundwater through porous rock is guided by gravity and pressure, forming hidden streams that feed springs and rivers. These subsurface flows carry minerals that enrich soils and sustain ecosystems far from precipitation sources. Scientists study these aquifers to understand water availability, revealing how unseen currents sustain civilizations, forests, and grasslands, linking distant environments in a subterranean network of nourishment. Oceans reflect sunlight differently at various depths, producing a palette from turquoise to deep indigo. The absorption and scattering of light influence heat distribution, driving thermohaline circulation that moves nutrients and oxygen through marine ecosystems. Phytoplankton at the surface harness sunlight to create energy, forming the foundation of complex food webs that support creatures from microscopic zooplankton to massive whales. Water's ability to dissolve gases such as oxygen and carbon dioxide supports aquatic life and regulates atmospheric balance. Streams, lakes, and oceans act as natural reservoirs, allowing exchanges between air and water that affect respiration in organisms and photosynthesis in plants. This constant interaction sustains biodiversity, stabilizes climate, and demonstrates the chemical versatility that makes water essential to life on Earth. Glacial ice slowly shifts across polar landscapes, compressing layers formed over centuries into dense, blue-tinged masses. Crevasses open and close, releasing meltwater that travels through tunnels beneath the glacier. This movement sculpts valleys, deposits moraines, and contributes to river systems far from the ice sheet, creating dynamic habitats and shaping both the visible and hidden architecture of polar and subpolar regions. Rain infiltrates rocky cliffs and karst landscapes, dissolving limestone to form caverns, sinkholes, and underground rivers. These subterranean channels harbor unique species, including blind fish and invertebrates, adapted to darkness and scarce nutrients. The interaction between water and rock slowly transforms the land above, leaving geological fingerprints that reveal the power of flowing moisture to shape landscapes over millennia. Surface tension enables water to form droplets that cling to leaves, spiderwebs, and narrow channels. These suspended beads nourish microhabitats, provide hydration for insects, and influence seed dispersal in forests and meadows. As droplets merge and fall, they deliver subtle pulses of moisture, demonstrating how molecular cohesion orchestrates life on a scale both visible and microscopic across ecosystems. Hot springs emit mineral-rich water that fosters microbial mats in vibrant hues of orange, green, and red. These thermophilic communities convert chemicals into energy, thriving in conditions lethal to most organisms. The interaction between heat, minerals, and water creates spectacular visual patterns and sustains rare life forms, offering insights into extremophiles and the resilience of ecosystems that rely entirely on aqueous chemistry. Water vapor carried by winds influences precipitation patterns thousands of kilometers away. Evaporation from oceans, lakes, and rivers forms clouds that drift across continents, releasing rainfall that nourishes crops, forests, and urban areas. This invisible transport system links distant environments, connecting deserts to rainforests and polar regions to tropics, illustrating the subtle yet immense impact of water as it moves through the atmosphere. Ice crystals in high-altitude clouds scatter light, producing halos, sundogs, and iridescent patterns that shimmer across the sky. These formations indicate moisture content and atmospheric conditions, subtly affecting solar radiation and climate dynamics. Pilots, mountaineers, and meteorologists observe such displays to anticipate weather changes, while artists and photographers capture their fleeting beauty, revealing water's role as both a scientific and aesthetic phenomenon in the skies. Riparian zones along rivers host dense vegetation, filtering sediments, moderating flow, and providing shelter for wildlife. Trees and shrubs intercept rainfall, their roots stabilizing soil and promoting nutrient cycling. Aquatic and terrestrial species interact in this interface, dependent on water levels and seasonal floods, demonstrating the importance of flowing water in creating transitional ecosystems that sustain biodiversity and maintain landscape health. Water's molecular polarity allows it to adhere to surfaces, a property essential for capillary action in plants. This enables sap to rise through stems and leaves, delivering nutrients from roots to foliage. By defying gravity on microscopic scales, water sustains forests, grasslands, and gardens, illustrating the remarkable ways molecular behavior supports life across ecosystems, from deserts to rainforests. Water vapor has been observed on the dwarf planet Pluto, escaping slowly into space from its frozen surface. Seasonal heating causes sublimation, creating tenuous atmospheric layers that expand and contract with orbital cycles. These phenomena demonstrate that H2O, even in trace amounts, can actively shape climate and surface features on distant icy worlds, connecting cryospheres to atmospheric dynamics across the solar system. Hydrated minerals on asteroids, such as carbon-rich bodies, indicate that water once interacted with rock long ago. These materials preserve evidence of aqueous alteration, hinting that asteroids contributed water to early Earth. By analyzing meteorites and remote observations, scientists track the history of water in the solar system, revealing its role in planetary development and the chemical evolution of solid bodies beyond Earth. Submerged estuaries blend freshwater and saltwater, creating brackish habitats with high productivity. Nutrient-rich sediments support fish nurseries, bird populations, and diverse plant communities. Tidal flows continually renew oxygen and organic material, fostering complex food webs. These transitional waters demonstrate the dynamic influence of water mixing, where chemical gradients, currents, and tides shape vibrant ecological mosaics at the land-sea interface. Water flowing over cliffs forms waterfalls that aerate rivers, dissolve rock, and sculpt valleys. Mist rises from impact zones, creating ephemeral rainbows and microclimates for mosses, ferns, and amphibians. The kinetic energy of falling water sustains oxygen levels for aquatic life and supports downstream ecosystems, illustrating how vertical motion of water combines beauty, power, and ecological function in a continuous, mesmerizing display. Cloudbursts over tropical mountains deliver sudden torrents, saturating soils, triggering landslides and swelling streams. These events redistribute nutrients and sediments, while reshaping terrain. The ephemeral yet intense nature of such storms demonstrates water's capacity to transform landscapes in hours rather than centuries, revealing the delicate balance between rainfall, topography, and the resilience of flora and fauna adapted to sudden inundation. Brine pools in the deep ocean form pockets of hypersaline water, denser than surrounding seawater. Unique organisms inhabit these extreme environments, using chemical reactions instead of sunlight to survive. The pools create sharp visual boundaries, resembling underwater lakes, and provide scientists with clues about life's adaptability and the chemical diversity of water in habitats far removed from surface conditions. Seasonal floods replenish wetlands, deposit nutrients, and connect rivers to lakes and marshes. Birds, fish, and amphibians rely on these inundations for breeding, feeding, and migration. Floodwaters shape soil fertility and maintain ecological networks, demonstrating the interplay between episodic water events and long-term ecosystem health, while providing dramatic shifts in landscapes that are both vital and visually striking. Rain seeps into soil layers, moving slowly through pores between particles and nourishing plants, fungi, and microbes. This infiltration regulates groundwater levels, stabilizes soil temperature, and prevents erosion, ensuring fertile landscapes. The movement of water underground forms a hidden network connecting surface ecosystems, demonstrating how liquid moisture quietly underpins life on land while shaping topography over decades and centuries. Water flowing over rocks in streams gradually wears down stones, polishing surfaces and forming smooth channels. Pebbles and sediments carried along the current alter the streambed's shape, influencing aquatic habitats for insects, fish, and amphibians. The rhythmic movement of flowing water generates oxygen, distributes nutrients, and sustains life, highlighting how continuous motion shapes landscapes and sustains ecological networks over long periods. Fog drifts across valleys at dawn, condensing on plants and soil, releasing moisture slowly into the environment. This atmospheric water nourishes mosses, ferns, and small insects, while moderating temperature and humidity in microhabitats. The interplay of light filtering through mist transforms familiar landscapes into ethereal, shifting scenes, illustrating how water subtly alters both ecological conditions and visual perception of the world. Springs emerge where groundwater reaches the surface, often carrying dissolved minerals that color rocks and sediment. These constant flows provide drinking water for animals, hydrate plants, and feed streams. Over time, springs sculpt channels, enrich soil, and support surrounding ecosystems. Their persistent movement highlights the invisible connection between precipitation, aquifers, and surface life, emphasizing water's central role in sustaining terrestrial environments. Mountain glaciers slowly advance, grinding underlying rock and transporting sediments in their frozen mass. Seasonal melting releases meltwater that forms streams and rivers downstream, enriching soils, sustaining plants, and providing habitats for fish and insects. The dual action of erosion and deposition transforms valleys, creating fertile floodplains, waterfalls, and lake basins, illustrating how ice and water together continuously shape landscapes over millennia. Water flowing through wetlands filters pollutants, absorbs nutrients and moderates floods. Marshes and swamps host diverse wildlife, from amphibians to migratory birds, while regulating water flow into rivers. This natural cleansing system demonstrates how ecosystems rely on the movement of water to maintain health, showcasing the intricate interplay between hydrology, vegetation, and fauna in sustaining both ecological and human needs. Raindrops striking leaves and soil create a network of ripples and puddles that nourish plants and support microbial life. Each droplet's kinetic energy aerates the soil and contributes to chemical interactions vital for nutrient cycling. This continuous contact between precipitation and land highlights how falling water fosters fertility and biodiversity, linking atmospheric events to terrestrial ecosystems in subtle yet profound ways. Water stored in aquifers slowly moves through layers of rock and sediment, supplying wells and springs. This hidden flow replenishes rivers and maintains soil moisture during dry periods. Studying aquifers reveals how groundwater underpins human civilization, agriculture, and natural habitats. The invisible, steady movement of water underground demonstrates its critical role in linking rainfall, surface landscapes, and the health of ecosystems over time. Oceans store vast amounts of heat, distributing it through currents that regulate global climate. Warm water moves from equatorial regions toward poles, while cooler water returns along deep currents. This circulation supports marine ecosystems, transports nutrients, and influences weather patterns worldwide. The enormous thermal capacity of water demonstrates its ability to stabilize environments, making oceans critical regulators of both life and climate on Earth. Water in interstellar clouds forms icy mantles around dust grains, providing the raw materials for star and planet formation. In these cold, dense regions, molecules accumulate and undergo chemical reactions, creating a rich inventory of prebiotic compounds. When stars ignite, some of this water is incorporated into new planetary systems, illustrating how the cosmic cycle of H2O seeds potential habitats long before planets exist. The Moon has water ice hidden in permanently shadowed craters near its poles, preserved for billions of years. Despite low temperatures and minimal atmosphere, these ice deposits could support future human exploration. Robotic missions have confirmed its presence, revealing that even airless bodies can harbor essential resources and demonstrating how water persists in extreme, airless extraterrestrial environments. Water vapor rising from rivers, lakes, and oceans forms clouds that drift with atmospheric currents. These clouds deliver precipitation to distant landscapes, feeding forests, crops, and rivers. The journey of water from surface to sky and back illustrates the interconnectedness of Earth's systems, showing how moisture transported invisibly through the atmosphere sustains terrestrial life while shaping climates across continents. Icebergs floating in polar seas carry sediments, minerals, and microorganisms embedded in frozen water. As they melt, nutrients are released into surrounding waters, sustaining plankton blooms and supporting marine food webs. Their slow drift reshapes coastlines and influences ocean circulation patterns. This frozen movement demonstrates how ice acts as both a reservoir and transporter of life-sustaining water and minerals in cold environments. Seasonal floods reshape river valleys by depositing fertile sediments and creating new channels. Floodwaters replenish wetlands, nourish vegetation, and provide breeding grounds for fish, birds, and amphibians. The cyclical rise and fall of rivers demonstrates how water acts as both sculptor and sustainer, balancing destruction with renewal and connecting terrestrial and aquatic life through rhythmic, life-giving movement across landscapes. Snow accumulating in mountains compresses into dense ice over years, forming glaciers. These frozen reservoirs store fresh water that slowly melts during warmer months, feeding rivers and streams downstream. This gradual release maintains aquatic ecosystems, agricultural regions, and human settlements, demonstrating how water stored in solid form controls the timing and availability of resources, shaping both natural and human landscapes across vast regions. Water in lakes absorbs and stores sunlight, creating temperature layers that influence aquatic life. Surface layers support photosynthetic algae and plant growth, while cooler, deeper layers retain oxygen for fish and invertebrates. The interplay of light, heat, and water chemistry creates stratified habitats, demonstrating how a single body of water contains multiple microenvironments essential for sustaining complex ecosystems. The dwarf planet Ceres hosts bright spots in craters, primarily composed of salts and water ice exposed by impacts. Observations suggest briny liquid beneath its surface, creating transient flows that may resemble frozen springs. These discoveries show that even small celestial bodies can retain water over billions of years, challenging assumptions about H2O distribution and providing insights into the early evolution of the solar system. Water molecules detected in the atmospheres of Venus appear in trace amounts within dense clouds of sulfuric acid. While Venus's surface is inhospitable, the presence of water at higher altitudes influences cloud chemistry, atmospheric circulation, and thermal regulation. These microscopic quantities reveal that H2O interacts with extreme planetary conditions, contributing to the ongoing study of greenhouse dynamics and atmospheric stability beyond Earth. Rainwater percolating through forest litter nourishes the soil, fueling microbial activity and decomposition of organic matter. This moisture supports root growth, recycles nutrients, and maintains forest health. By connecting canopy rainfall to subterranean life, water facilitates an intricate web of ecological interactions, ensuring the continuous vitality of plants, fungi, and microorganisms that together sustain terrestrial ecosystems. Streams and rivers transport dissolved minerals and sediments from mountains to plains, shaping valleys and fertile floodplains. Along the way, moving water creates riffles and pools that support diverse aquatic species. This movement not only sculpts landforms, but also distributes life-sustaining materials, demonstrating how dynamic flow transforms terrain and sustains ecosystems over decades and centuries. Ice forming along lake edges in winter insulates underlying water, protecting fish and microorganisms from freezing temperatures. The thickness and clarity of ice influence light penetration, affecting photosynthesis and food availability beneath the surface. Seasonal freeze-thaw cycles maintain ecological balance, demonstrating how water in solid form preserves life while shaping habitats over time. Water droplets on leaves from dew or light rain provide hydration for insects, spiders, and microorganisms. These droplets influence seed germination, plant growth, and local humidity. The minute interactions between surface water and organisms illustrate the pervasive impact of liquid moisture, showing that even small quantities can sustain complex networks of life in ecosystems ranging from forests to grasslands. Shorelines evolve as waves and currents erode rock and redistribute sand, forming beaches, cliffs, and tidal flats. This constant movement creates habitats for birds, crustaceans, and marine plants, while maintaining sediment balance. Water's persistent energy sculpts landscapes over years, demonstrating the dynamic interaction between liquid motion and land, and highlighting the essential role of flowing water in coastal ecology. Comets carry water ice within their cores, often mixed with dust and organic molecules. As they approach the Sun, sublimation releases gas and ice, forming spectacular tails. These icy travelers are thought to have delivered water and prebiotic compounds to early Earth, illustrating how cosmic reservoirs of H2O contribute to planetary formation, atmospheric evolution, and the potential origins of life across the solar system. Titan, Saturn's largest moon, has lakes and rivers composed of liquid methane and ethane, yet evidence suggests water ice beneath the surface forms a solid crust over a possible subsurface ocean. The presence of water alongside hydrocarbons indicates complex chemistry, with cryovolcanic activity likely bringing subsurface H2O closer to the surface. Titan serves as a laboratory for understanding water's interaction with exotic solvents beyond Earth. Water trapped in peat bogs slowly accumulates over centuries, creating thick layers that preserve plant material, pollen, and even ancient insects. These saturated landscapes release moisture gradually into surrounding soils and streams, supporting unique flora and fauna adapted to acidic, low-oxygen conditions. The stored water moderates local hydrology, providing habitats for amphibians, birds, and specialized plants, while recording a historical archive of environmental change. Oceans absorb carbon dioxide from the atmosphere, forming weak carbonic acid that influences global pH levels. This interaction regulates climate and supports marine life by affecting calcium carbonate formation, critical for corals and shellfish. The subtle chemical equilibrium demonstrates water's capacity to connect atmospheric conditions with aquatic ecosystems, showing how H2O mediates environmental balance on scales ranging from microscopic organisms to global biogeochemical cycles. Water flowing through karst landscapes carves limestone into tunnels, sinkholes, and underground rivers. Over thousands of years, these hidden channels create caves and subterranean pools that sustain rare fish and invertebrates adapted to darkness. Rainwater enriched with dissolved carbonates gradually shapes both subterranean and surface topography, illustrating how movement of water sculpts geological formations while providing critical aquatic habitats in otherwise dry regions. Tidal currents move nutrients, sediments, and organisms along coastlines, influencing the distribution of marine plants and animals. The repeated rise and fall of water shapes intertidal zones, creating habitats for crabs, mollusks, and shorebirds. These oscillating flows maintain productivity in estuaries, mudflats, and mangrove forests, showing how cyclical water movement fosters ecological diversity while balancing coastal landscapes over decades. Snow that accumulates in high latitudes reflects sunlight, regulating surface temperatures and slowing seasonal melt. When it begins to thaw, water percolates into soils and streams, nourishing plants and animals. This frozen storage system acts as both reservoir and climate moderator, demonstrating how solid phase water integrates energy balance, seasonal cycles, and ecosystem function in polar and mountainous regions. Rainwater collects in ponds and wetlands, creating small ecosystems that support amphibians, insects, and migratory birds. These ephemeral bodies regulate water tables, filter nutrients, and sustain microorganisms that recycle organic matter. Seasonal variation in water levels triggers breeding cycles, and dispersal patterns, showing how modest concentrations of liquid water maintain complex ecological interactions across terrestrial landscapes. Water molecules in rivers and lakes carry dissolved oxygen, enabling fish, invertebrates, and aquatic plants to thrive. Flowing currents distribute this oxygen while transporting nutrients and sediments downstream. The combination of chemical and physical movement creates layered habitats where species coexist, demonstrating how water's dynamic properties maintain life-sustaining balance in freshwater ecosystems across diverse geographical regions. Subglacial lakes exist beneath kilometers of ice, isolated from the surface for millennia. These liquid reservoirs are maintained by geothermal heat and frictional pressure, providing habitats for microbes adapted to darkness, cold, and high pressure. Studying these hidden waters informs scientists about the resilience of life in extreme conditions and suggests analogues for potential extraterrestrial oceans beneath icy moons and distant planets. Water in coastal mangrove forests stabilizes shorelines by reducing erosion and buffering storms. The complex root systems trap sediments, improve soil fertility, and create habitats for fish, crabs, and birds. Tidal waters deposit nutrients, supporting lush growth and high biodiversity. This interplay of flowing water, rooted vegetation, and sediment demonstrates the essential role of H2O in maintaining both ecological stability and human coastal resources. Rain seeping into mountainous valleys nourishes mosses, ferns, and understory plants. Tiny channels within rocks and soil carry water to springs and streams, sustaining ecosystems far from direct precipitation. The slow movement of moisture maintains rivers, wetlands, and soil fertility, highlighting the delicate, interconnected journey of water from clouds to the depths of the earth, linking microhabitats with broader landscapes. Ice forming along riverbanks in winter shapes, microhabitats for overwintering fish and insects. The ice insulates underlying water, preserving oxygen and maintaining liquid layers where life persists. Seasonal freeze-thaw cycles sculpt riverbeds, influence sediment transport, and create niches for algae and microorganisms. This rhythmic transformation demonstrates how water's phase changes shape both physical environments and the survival of aquatic organisms through harsh climates. Fog drip, or horizontal precipitation, delivers moisture to plants in arid and mountainous regions where rainfall is scarce. Leaves, mosses, and soil absorb suspended droplets, supporting delicate ecosystems and preventing desiccation. These hidden flows of water sustain insects, small mammals, and birds, showing how atmospheric moisture can act as a lifeline for terrestrial life in areas otherwise dependent on minimal precipitation. Water flowing through floodplains distributes nutrient-rich sediments across wide areas, creating fertile soils for plants and agriculture. Seasonal inundation encourages fish spawning, bird migration, and wetland development. The subtle reshaping of land and deposition of minerals highlights how water acts as a sculptor, builder, and sustainer, linking hydrology with long-term ecosystem productivity while preserving biodiversity across connected landscapes. Springs emerging in volcanic regions often carry heated, mineral-rich water that nourishes plants and animals in surrounding areas. The The dissolved minerals support unique microbial mats, algae, and invertebrates, forming ecosystems distinct from those in normal rivers. The combination of temperature, chemical composition, and continuous flow demonstrates how localized water sources shape biodiversity and maintain habitats within challenging geological environments. Mars hosts frozen water in polar ice caps, composed primarily of water ice with seasonal layers of carbon dioxide ice. During warmer seasons, sublimation exposes water-rich terrain, and recent findings suggest transient briny flows on slopes, revealing that Martian water can exist in both solid and liquid forms. This cyclical behavior informs our understanding of planetary climate history and the potential for life in extreme environments. Water vapor has been detected in the thin atmospheres of exoplanets, sometimes forming clouds of ice crystals or droplets under specific temperature and pressure conditions. These distant worlds demonstrate that liquid or frozen water is not unique to Earth. By observing spectral signatures, astronomers trace the cosmic distribution of H2O, revealing its essential role in shaping atmospheres, climate, and potentially habitability far beyond the solar system. Water in ephemeral desert streams creates temporary habitats for amphibians, crustaceans, and plants. Even brief flows transport sediments and seeds, enriching soils and providing short-lived nourishment for wildlife. These sporadic waterways illustrate how water's presence, however fleeting, can dramatically influence desert ecology, sustaining life and seeding vegetation in landscapes otherwise dominated by aridity and scarcity. Glacial lakes formed by ice melting in high-altitude valleys carry sediments and minerals downstream, enriching soils and creating habitats for fish and birds. The slow release of water sustains streams and wetlands far below, linking elevated terrain to plains. These natural reservoirs demonstrate how frozen water shapes landscapes, supplies ecosystems, and maintains hydrological balance across vast mountainous regions. Ice shelves floating on polar oceans act as barriers to glacial flow while storing immense amounts of fresh water. As they fracture or melt, icebergs drift into open seas, delivering nutrients and shaping ocean currents. This frozen water influences ecosystems both beneath and around it, demonstrating the interconnectedness of terrestrial ice, marine life, and global hydrological cycles on Earth. Water, moving through forest streams, nourishes aquatic insects, fish and mosses, while eroding rock surfaces, creating pools and riffles. The constant circulation oxygenates water and distributes nutrients, supporting complex food webs. Streams act as ecological arteries, linking mountains, valleys, and plains, illustrating how flowing water maintains biodiversity, shapes terrain, and sustains life across connected terrestrial landscapes. Shoreline wetlands absorb tidal waters, filter pollutants, and provide habitat for amphibians, crustaceans, and migratory birds. These water-saturated areas stabilize coasts, prevent erosion, and store floodwaters, demonstrating the essential function of liquid water in maintaining both ecological integrity and resilience against environmental variability. Through the interplay of tides, vegetation, and sediment, wetlands illustrate the subtle yet powerful influence of water on life and land. Ganymede, the largest moon of Jupiter, contains a subsurface ocean beneath a thick ice shell along with a tenuous oxygen atmosphere. The interaction of water with magnetic fields creates auroras and induces subtle shifts in surface ice. These phenomena illustrate how water's presence influences both planetary geology and electromagnetic environments, hinting at the complex interplay between liquid, solid, and energetic forces in space. On Saturn's moon, Enceladus, geysers eject water vapor, ice grains, and organic compounds from a subsurface ocean through fissures in the icy crust. These plumes contribute to Saturn's E-ring and suggest hydrothermal activity below. The discovery of these active jets reveals that liquid water exists under extreme conditions, supporting ecosystems in isolation and offering scientists a rare opportunity to study extraterrestrial ocean worlds. Snow accumulating in alpine forests melts slowly, feeding moss-covered rocks, seedlings, and forest streams. The meltwater maintains soil moisture, prevents frost, damage, and supports insects and small mammals during early spring. By storing water in frozen form, these high-altitude regions regulate river flow and maintain habitats for species adapted to seasonal transitions, showing the protective and sustaining nature of liquid release from ice. Oceans absorb heat unevenly, creating currents that redistribute warmth across the globe. These movements influence weather patterns, nutrient flow, and marine ecosystems. Upwelling zones bring mineral-rich water from the depths, fueling plankton blooms and sustaining fish populations. Through this continuous circulation, water acts as both a thermal regulator and ecological transporter, linking surface and deep-sea life in a complex, interdependent network. Water droplets collected on desert plants from morning condensation sustain insects, lichen, and small mammals. Though minimal in volume, this moisture is critical for survival in arid ecosystems. The interaction of air, surface temperature, and vegetation enables life to persist in extreme conditions, demonstrating how even minute quantities of water create microenvironments that maintain delicate ecological balance in dry landscapes. Glacial moraines deposited by retreating ice act as natural dams, forming lakes and wetlands. These water bodies host amphibians, fish, and aquatic plants, while storing seasonal meltwater. Over centuries, moraines alter valley drainage and sediment distribution, shaping topography. This demonstrates the interplay between frozen water, geological debris, and liquid hydrology in creating long-lasting habitats and maintaining ecological continuity. Ephemeral desert pools formed after rare rainfall act as breeding sites for amphibians and insects. These temporary waters replenish soil moisture and deposit nutrients, supporting rapid plant growth and attracting migratory birds. Despite their fleeting existence, these pools demonstrate water's critical role in desert ecology, revealing how brief availability can trigger life cycles and create microecosystems in otherwise harsh, arid conditions. Ice forming along mountain lakes insulates liquid water beneath, preserving oxygen for fish and microorganisms during harsh winters. Seasonal freeze and thaw cycles sculpt shorelines, create ice formations, and influence nutrient distribution. These transitions reveal how frozen water sustains ecosystems while actively shaping habitats, illustrating the adaptive strategies of aquatic organisms in regions with extreme temperature fluctuations. Streams that carve through volcanic landscapes distribute mineral-rich sediments downstream, enhancing soil fertility and supporting vegetation. Aquatic insects, fish, and amphibians thrive in these channels, while riparian plants stabilize banks and intercept runoff. The movement of water shapes both geology and biology simultaneously, highlighting its role in maintaining fertile landscapes and dynamic ecosystems, even in geologically active regions. Ice on Mercury persists in permanently shadowed craters near the poles, shielded from the sun's relentless glare. Despite the planet's proximity to intense heat, these frozen deposits, likely mixed with dust and rock, provide a glimpse into how water can survive in extreme, seemingly inhospitable conditions, hinting at the resilience of H2O even under cosmic extremes, where temperatures fluctuate dramatically across the surface. Europa, one of Jupiter's moons, hides a vast subsurface ocean beneath an icy crust. This ocean, potentially twice the volume of Earth's seas, is kept liquid by tidal heating from Jupiter's gravity. Scientists speculate that hydrothermal vents at the ocean floor could harbor life, making Europa a prime candidate in the search for extraterrestrial ecosystems sustained entirely by water beyond our planet. As our journey through the flowing worlds of water comes to a close, allow yourself to sink even deeper into relaxation. The rhythmic rise and fall of ocean waves, and the soft trickle of a forest stream winding its way through mossy rocks. Let the soothing sensations of peace and calmness envelop your body and mind. Feel your thoughts gently fading, your muscles softening, and your breath flowing naturally and effortlessly. Rest here, fully supported in this safe and serene space. If you enjoyed this relaxing moment, please consider leaving a like, subscribing, and turning on all notifications so you don't miss any of our future videos. But for now, let your body relax, release any tension, and allow your mind to drift. Good night and sleep well.